So now that we've seen that a tangent line can tell us about the slope of a function at a single point, just how do we go about making one? Are we expected to draw a line given only one point? The answer is yes and no. Yes, because ultimately that's what we really want, but no, because we have to aim the tangent line in the same direction that the function curve is heading, and that requires 2 points. So to get to our 1-point goal, we'll take advantage of local linearity and begin with 2 points on the function graph. One will be our tangent point P, the point where we want the instantaneous rate of change. The other point we're going to call Q. So here's point P. We're going to draw a tangent line through P. So this line touches the curve only at one point, and yet it's going in the same direction as the curve at that point. So how do we actually make that happen? How do we compute the line to make that tangent line? And the way we're going to do this is by starting with another point Q on the function. We're going to draw what's called a secant line between point P and Q. And then we're going to move Q closer to P. So as I do that, watch what happens to the green secant line. It becomes more and more like the red tangent line. In fact, as I get really super close, they're practically indistinguishable. And this can be done from either direction. I can approach P with Q from this direction, and the same thing happens. Closer I get with Q and P, the more the secant line looks like the tangent line. Now I can calculate the slope of the secant line PQ by calculating the difference in x and the difference in y. Slope is just going to be delta y divided by delta x. So the closer I get, the smaller those two values get. I'm going to get closer and closer to the tangent line slope. Problem is, right when I get to where P and Q are the same point, delta x becomes 0. And if there's no change in x, then there can't be any change in y. My slope is now 0 over 0, which is not something that I can deal with mathematically. And so this is going to be the first obstacle we run across in developing the tangent line.